buenas. Vamos a dar inicio con esta actividad. La verdad nos motiva muchísimo tener dos invitados super especiales acá en la sede. Ellos son Víctor Farsic.
Sí, está bien.
Sí. Él es, bueno, dice que es developer, él es autor de DevOps Toolkit y referente en el tema de Kubernetes, DevOps and CD. Y Whitney Lee, ¿verdad? Quien es comunicadora, es también embajadora del CNCF y creativa en el mundo del Cloud Native. Presenta shows y hace de la tecnología algo divertido y bastante fácil de entender. Ellos estuvieron el sábado pasado en un evento que se llamaba KCD, que es el Kubernetes Community Day, y tienen el placer de venir a la sede, ¿verdad? Y también esa colaboración con nosotros. La verdad es que le agradecemos un montón a los dos porque nos encanta tener este tipo de actividades. Creo que eso enriquece muchísimo la carrera. Ambos, creo que la presentación va a ser en inglés, la actividad, ¿verdad? Cualquier cosa, Víctor habla español, entonces le puede preguntarse en español. Y si no, la profe Laura, a quien le agradecemos un montón a la carrera de inglés que nos ha ayudado, ¿verdad? Con todo esto, les puede colaborar con el tema de si tienen alguna consulta o demás, ¿verdad? Para hacerles a ellos. También es parte de, o sea, al hacer este tipo de actividades también en idioma inglés, fomenta el tema de la acreditación de la carrera, que es uno de los requisitos, ¿verdad? Que también tengamos actividades en otro idioma. Entonces, sin más preámbulo, los recibimos con un fuerte aplauso y le damos la bienvenida a los compañeros invitados.
Who here knows what cloud native is? Raise your hands. Has any experience with cloud native computing? A little bit. I see a Kubernetes t-shirt here, a little bit over here. Okay, just trying to get an idea for where you're at to help you know, to help know what we should talk about. And also I want to tell you that I also knew almost nothing just a short while ago. So to help get you interested in cloud native, the first thing that we're going to do is I'm going to tell my story because it's a fun story. So here we go. That's me. I drew these slides. I'm waiting here. I'm an international keynote speaker, so is Victor. He's in some of these photos too. And I actually spent most of, here's me and Victor. We're in Shanghai, China, giving a keynote speech here at KubeCon. The Cube in KubeCon is for a technology called Kubernetes. And here, this is me giving a keynote in Detroit in 2022, and that's me. So this has room with 10,000 people in it. And what's cool about this is I gave my first talk ever only 6 months before this. So my first talk ever to a room full of 20 people happened in April, and this is October of 2022. So there's a lot of opportunity to grow in cloud native. This is at my previous employer, VMware Tanzu, and then I give lots of smaller keynotes, which is why we're here in Costa Rica. Yes. So Austin, Texas is my home, and I've done a lot of things in my career. So I was very shortly a fine artist, and I drew all the slides. I made this deck. For most of my adult life, I've been a photographer, and I photographed weddings mostly. But here's the thing, I hated it. It was the worst. I hated it so much. It was lots of repetitive work, and I didn't have a lot of chance to grow, and lots of different feelings that I had to deal with people's feelings, although that happens in software too. So when my brother's band experienced some success and I had a chance to go on tour in the band, and I was like, yes, and I quit my photography job that I've had for over 10 years. I do have a college degree, and my college degree is in fine art and photography. So I quit my photography job, and I went on tour with my brother and his bands for a year, and we got to tour the world. And then when I came back from that in 2014, I didn't know what I wanted to do with my life. I knew what I did not want to do with my life, and that's wedding photography. It's the worst. Don't do it. So I drove for Lyft, which is like Uber, like a ride share in Austin. And then I also worked at restaurants. I worked at a fancy sushi restaurant, and then later I worked at a hippie, the vegan cafe, which is much more my speed. And meanwhile, my son was going to college, and he was like, hey mom, I think you would like technology, I think you would like coding. And I was like, okay, I'll try it. So because of my son, he's the one who got me into coding, and that was in 2019. And so then I went to, I started practicing first. And I did lots and lots of practicing and got into a coding boot camp. Do you have those kinds of coding schools here that are where you go, like, for mine I went 12 hours a day, 6 days a week, and it lasted only 3 months. But I had to do a lot of preparation before I got in. So I basically did nothing but code for all of 2019 to get through this program. And then I interviewed for a job at IBM where I had to learn Kubernetes for the job interview. And what I learned in boot camp was full stack web development, which I understand is close to what you're learning, is that right? Yeah, And then what I applied for was a job doing DevOps and cloud computing, which is actually very different, but I didn't know how different it was. So to learn about Kubernetes, I looked at YouTube videos, and I was applying for a job at IBM, so I looked at these IBM Cloud Lightboard videos, and that's how I first learned about Kubernetes for the job interview. And then lo and behold, only 11 months after writing my very first line of code, I got a job as a cloud developer at IBM. But cloud development, cloud technologies, it's a lot. It's very vast. How you deploy your application differently, how you run it across multiple computers, lots of different issues like scaling and resiliency, and I didn't know how different it was from what I've been studying, and I'm glad I didn't know, because I was able to learn it, but it was overwhelming at first. So when I first started at IBM, I felt like an imposter. I was like, I don't know any of this stuff. I don't understand what's happening around me. They're paying me a lot of money to be here. I feel like I should be contributing more to what's going on around me. And I didn't know things, some of the basic vocabulary. So when people are talking about distributed computing, they're talking about lots of different computers that you're managing as one unit. And when they talk about all those different computers, they use different words. Like they'll call a computer a box, and they'll call it a node, and they might call it a machine. They might call it a VM. They might call it a host. They might call it a server. And it took me a long time to figure out they just meant computer the whole time that they were saying that. And so how did I get through that? Oh, here's another thing. I was very, very different than the other people around me. I'm significantly older than y'all, as you probably guessed, since I had my son here on the screen. My son's 26, and he works at Adobe as a full stack web developer there, front end. He works with React. So the people that I started working with at IBM were all much, much younger than me, and they were also almost all men. There were maybe 10% women in cloud computing. So any women in this room, you can do it. Come on, I'm rooting for you. Yes, yes, yes. We want you here. So I felt very different, but I was getting paid a lot of money. So I'm like, I'm gonna make this work. So I studied a lot. There were a lot of virtual meetings. It was during the pandemic. And so everyone had their camera off, and even though they were boring and I couldn't see anyone and I barely knew what was happening, I took a lot of notes and I made flashcards and I did my very best to understand what was happening and why. I love this flashcard, this spaced repetition learning program called Anki. So when I say I made flashcards, I use this program in particular. I got myself a mentor. This is my real mentor, Maurice. He was more of a career mentor. And again, nobody said, hey, Whitney, you need a mentor. I was just like, I feel overwhelmed. I'm going to find a person and just ask them to be my mentor. And I did. And he said yes. I put him in a position where it was very hard to say no. Victor understands. And so I was also learning what it felt like to work at a big company. So I asked, people would say, Q2, we got to do this in Q2, and I had no idea what that meant. You probably don't want to know what that meant, and that's okay. They mean quarter two, and they'll also say 1H and 2H for the first half of the year and the second half of the year. And it feels kind of silly and arbitrary, but what they're talking about is stocks prices. So at a publicly traded company, they're trying to show that they are making more money this quarter than they were last quarter. So they always have these deadlines, Q2, oh, the next quarter we got to get this feature done in time for this. So these quarters are meaningful. Is that about right? Why people care about quarters?
And nobody knows when the quarter starts.
Nobody knows when a quarter starts.
It's not a calendar.
Different companies might do it differently. Yeah. I honestly, all the corporate stuff, I don't care about. I just tune it out because I like the tech and I just concentrate on the things that are interesting to me, which is not any of the business stuff. But Maurice was awesome. He was great in helping me navigate corporate life. He was good about helping to introduce me to other people in the company or helping me know what I should learn about next. And when it was time to came eventually for me to get a promotion, he was in my ear telling me to push for a promotion, which was awesome. So I was learning Kubernetes. And while I was working on it, this is a program called Slack. It's a very popular way for people in a corporation to talk with. It's like Teams, yes. It's just like Teams, or like Discord, but for corporations.
Just not horrible.
Yeah, Teams is the worst. I do literally hate Teams deeply, as much as I hate wedding photography, which is a lot. So in Slack, there was this message that went up like, hey, we're looking for SMEs in Austin to be a part of the IBM Cloud YouTube channel to help give explainer videos for their Lightboard. And I was so new to tech that the first thing I did when I saw this post is I had to Google what is an SME? Like, what does the acronym SME even mean? And so it stands for subject matter expert. And I knew there was no world where I was a subject matter expert because at this point I'd been in cloud computing for like 6 months, which is not enough time to really understand what's happening. And the thing is, I thought maybe, like you saw, like I used to be in bands, like I'm comfortable in front of a lot of people, like maybe they just need a performer. And if that's the case, then I can do this. And it didn't say much in the post, so I had to fill out a form to say, yeah, okay, I'm interested. Let's hear some more. So then the pandemic happened, and so it went quiet for a while, and then once the offices reopened to essential personnel, the IBM Cloud YouTube team did reach out to me, and we got on a video call. And the big thing I remember about that video call is that they kept using the word rock star. And I was just like, what are you talking about? You don't know me. Like, I've only been here for a few minutes. I'm not at all qualified to be on your channel. I don't know why you want me here. But they said, for one thing, beginners do well teaching to other beginners, which I absolutely found to be true. And then for another thing, they said, you can, here's what we'll do. It's at a studio, it's not live, so just come in, learn something, come in and teach about it. If it's good, we'll put it on the YouTube channel, and if it's not good, then we'll throw it away, and there's nothing to lose.
And you'll get fired.
And then I'll be fired. They'll be sure I'm never hired again anywhere. So I was like, okay, sure, okay, they're low stakes, not much to lose, I'm gonna go for it. So the IBM Cloud YouTube channel, these are all marketing people, they're not technical people. So they weren't double checking that I wasn't saying something stupid. And so they should, right? There are like tens of thousands of people watching these videos. Somebody should be double checking me. Yeah, I agree. But nobody is. And so therefore I got another mentor. This is Rick. And I asked him So I asked Rick to be my technical mentor, and then basically what I wanted from him and what he did is I had a little whiteboard and a dry erase marker, and so I like basically did my video to him, what I wanted my video to be to him, and like drew on my whiteboard, and then he just told me, well, this jargon isn't quite right, like this vocab word, it would be better to say it like this, like little things, but just so I didn't look like an ass. He gave me that confidence. So this is my first video I ever recorded. This is behind the scenes in the IBM Cloud studio. And the first video I made was called What is etcd? Etcd is the data store that keeps track of all the configuration in Kubernetes. So I made a video about what is etcd and how does it work, and it's on the IBM Cloud YouTube channel even now. So I first learned what Kubernetes is in October, and then I made this video less than a year later. And it has something like 50,000 views, maybe 70, I don't know. But even now, if you Google what is etcd, this is the #1 video that comes up. And so it was horrifying, but it went well, and then I got a lot of positive feedback. I actually did not read the YouTube comments for a year because I just couldn't handle that, but I did get positive feedback from my teammates and my friends. And so I ended up, while I was at IBM, making a bunch more of them. And I think altogether they have 500,000 views, 700,000 views, something like that. So they're still going strong. But pretty quickly, I realized my job kept getting more. I got promoted into customer success, and I didn't like being a customer success manager. I wanted to be more technical. And I learned there's a type of job called a developer advocate, where your whole job is to speak at conferences and to make video content, to do blog posts or whatever. But your job is really to engage the community, learn the coolest stuff, play with it, talk about it. And I was like, I want that job. So I started looking around for developer advocate jobs. And I found one at VMware, specifically VMware Tanzu, and they had a job posting, and it called for deep Kubernetes expertise. And that was not me. I still was, that was not me at all. But for one thing, working with a lot of young American men were my colleagues, and they all had so much confidence about how awesome they were when they weren't. And I'm like, I'm at least as good as they are, and they have so much confidence, so why can't I have some of that confidence too? And so, and again, with the risk versus benefit ratio, like I have a lot to gain, but if I apply for this job and I'm underqualified, which I absolutely am, I'm going to talk to some people who might be nice. I'm going to learn more about what a developer advocate is and whether I even want to be one, and make some connections and practice interviewing. Like, I can handle a rejection if I understand like what I'm learning from the experience. So I said, I'm going to apply for it. Let's go for it. And I did not get the job. Well, I didn't get that job because I was not qualified. But they liked me so much as part of the interview process that they made a whole new job on the team just for me. So they made a job for a beginner who makes lightboard videos, and then they bought me a lightboard studio. So this is my house. This is a room in my house. I had a friend paint the clouds in the back. VMware did not help with that. I made it jazzy. But I have a lightboard studio in my house. And that's from being overconfident. No, I wasn't overconfident actually. I totally knew my place. I was open and honest and genuine. And so now, this is a video, but it's okay. Now I make lightboard videos. I have a streaming show called Enlightening. At first I was really nervous when I got that VMware job because I was so new and didn't know so much. And so I basically made a whole show about how much I don't know by inviting an expert to come on the show, and that expert is supposed to teach me everything there is to know about that technology from scratch. So if you can teach it to a beginner, then you can teach it to anyone. So I did this show called Enlightening where I made a lot of different shows, about 100 of these, of different technologies, different experts teaching me what's up. Now I'm a cloud native. There's a foundation called the Cloud Native Computing Foundation, and I'm a CNCF ambassador. slide here. Oh, I know why, because VMware laid me off. That happened last year. So VMware got bought by another corporation, Broadcom, and I got laid off, and I was upset about it for a while. But yeah, but now I have a new job at and I went hiking while I was laid off. It was great. And then and now I have a new job at Datadog, and I basically do the exact same job. I'm out in the community doing cool stuff. So I host a podcast with Kote, and then Victor and I together have a show called You Choose. Yes. And then Victor and I, we invited guests on, and our guests for You Choose only get 5 minutes to explain their technologies. And then we pit them against each other, and then we pit them against each other, and then we make the community vote on which one they like the best. And we build that into an ongoing demo. And I have this other show too called Thunder that I don't really feel like talking about. So that's where I am today. I have an awesome job. I get to be here with you right now. I get to make cool stuff. I get to hang out with Victor. I have to. And so here's some recommendations for how to get far. Be yourself. Be genuine. Don't pretend you know stuff you don't know. People can tell. And people will relate to you a lot more if you talk about the hard times instead of just saying how great you are. That's the same thing. Be vulnerable. Be curious. I think in technology, a lot of people like to have opinions and be like, oh, this one's better than that one. No, this is how it's done all the time. I think, in my opinion, everything exists for a reason. And so maybe you think technology is silly, and maybe it actually is ridiculous technology in this day and age, but it's interesting to understand that somebody liked it at some time, so why does it exist? Be kind to each other, but also be kind to yourself and your own mind. Loosen your identity. I feel glad that I wasn't like, I'm a front-end developer, I'm a full-stack developer after I graduated coding school. I was just like, I'm technical, and I can learn whatever. And so I think in general, if you have really strict ideas about who you are, then you're not giving yourself permission to become who you're supposed to be, who you're supposed to become. So having a broad idea, like I'm a technologist, or I'm creative, or whatever, I think it's wonderful. I really dislike when people say, I'm not technical. I was like, you can be technical if you want to be technical. Similarly, I can't draw. You can draw if you want to draw. Embrace change. Things are going to change. You're going to get laid off. You're going to decide you want to be a developer advocate. I think that's close to losing your identity, right?
Whatever you're learning now will be relevant by the time you finish.
Yes. Did you hear what he said? Whatever you're learning now is going to be irrelevant by the time you finish. Tech changes really fast, and it's best to just make that part of your learning journey and enjoy what you're learning in the moment. Don't get too attached. Anki is that flashcard deck that I love. I still make Anki cards and I still study them every day. And it's part of how I'm able to talk about new tech so effortlessly. That was an ironic word to mess up. Mentors and collaborators. I talked about mentors. So whenever I was unsure about myself, instead of saying, no, I'm not going to do this, I said, okay, how can I find someone to back me up and help? How can I lean on an expert to help me feel more confident about what I'm doing? And collaborators too. Sometimes there is someone out in the community who you just think is a badass and you want to collaborate with them, and you ask them and they say yes. And then you end up traveling the world together, so leave some room for that. And I'd say all the guests in my shows have been collaborators too. Being able to have conversations with experts every week has really accelerated my learning. That's it. That's it about me. We're going to talk with you, I think, about actual tech for a while. But if you see me around, say hello. I also brought a lot of stickers, so I'll happily give you my stickers. Stickers are my love language. So with that, do you want to hear more about what cloud native is? Is that a good place to start?
Yeah.
Okay, Victor, I'm going to let you have a turn. I've been dominating this conversation.
Keep going.
No, I want you to talk and I'll criticize you instead of the other way around.
haven't prepared anything. Keep going. Keep going.
This is what so Victor's 51 years old, and he's been doing this since he was 10. He's been doing it like 40 years. So Victor, I want you to give some context about what the world was like before cloud-native computing existed, to why it might need, what problem is it even solving? I would also like this to not be on my face anymore. We got enough on my face here.
I haven't really prepared anything, so I don't know what I'm going to talk about. But let's start with this. If you have any questions, that's going to make this so much easier. Any questions?
What was
Anything.
What was the world like before cloud-native computing?
So yeah, when it started with the abstract and Commodore and stuff like that, right?
Okay, I have a question.
Okay, go. That's so cool. Yes. Anything.
Why, like, starting for the description of what is
Cloud native?
What is the cloud?
like how you describe it?
Cloud native started, the movement that is now cloud native probably started officially maybe 15 years ago or 20. It wasn't called cloud native. That's when Heroku, probably nobody knows what is Heroku now.
No.
Heroku, yes. It's a service that allowed you to say, hey, here's my code, run it. And it would run it in servers, it would scale it, and so on and so forth. But that's not important. What is important is that Heroku folks, people who created that service, came up with 12 principles that somebody needs to follow in order to make an application work, right? And most of those principles are not directly related to the code, right? And actually, I think that if majority of you are focused almost exclusively on code, you're missing completely. You're focusing on 10% of what matters today in software, right? And those principles are like, never keep the state in your application. Your applications are always stateless. There is no way that I will remember all 12 principles, right? 12 factor apps. If you Google it, you will find 12 factor apps, that's all, right?
Disposability is one, like making your app so crash is a first-class citizen. It's going to fail, so let's design it where failing is what it does, as opposed to before where people didn't do that. Portability, yeah.
At that time, we started adopting cloud. Right now, cloud, everybody's running in cloud, but back then it was not so new, right? And people need a lot of guidance, how to run stuff in cloud, right? That's where this was born. And in the meantime, we got,
Do you know what it means when he says running in cloud? What that means?
AWS, Azure, Google Cloud.
The cloud is basically somebody else's computers. So the cloud is just like data centers of computers. So when you, like a server, it's servers, but the servers belong, like a long time ago, companies would have their own servers in their own company, and they would have someone who takes care of that. Now they rent servers from AWS or Google Cloud or Azure. And so that's what the cloud is that the idea that
basically it's being your ability to say, I want 5 servers, you get it like this, right? I want network between those servers, I want storage, I want the database, I want whatever. Basically everything is a service, right? It's like shopping on Amazon, more or less. Instead of you having physical server here and then connecting it to the cable or doing whatever you might be doing today. And the challenges that we were getting at that time is that everybody, back then, most of us were used to run applications simple, like, okay, I have a server, I put application code there. Most of you are probably using Java. I compile a Jar file, I put it on a server, I'm happy, I'm finished, that's what I do, right? But what was happening there is that was far from enough, because today, if you look at any company, right, it's not about your applications anymore, it's about how your application runs on 100 servers. How the users are being redirected to any of those 100 replicas of the application, right? Which is networking. Where do we keep files? Where do we keep data? And so on and so forth, right? And the first step towards getting where we are today was when Docker, the second step. The first step would be cloud. AWS. The second step was Docker, when Docker was extremely important, probably for reasons that most of you might not understand, and that's that it figured out how do we package our application so it doesn't matter what it is. You work with Java, you work with Python, you work with Perl, I don't care. They all run the same, they're all packaged in the same format, and they can run somewhere.
Do you know what containerization is? That's what he's talking about now. So basically before, in the before times, you at your company, you had a lot of computers. When someone on the internet wants to use your application, it's getting to your computers at your company. And those computers, each one, like this computer runs Java apps, this computer runs Python, this computer runs this language. And so with containerization, now we have a way to package up our applications so that the runtime and even the operating system is packaged with the application. So we can run a bunch of different kinds of applications all on the same computer now. And that's part of what helps containerization. And now they're also completely isolated from each other, so it's less of a security risk. That way we can scale. Yeah.
So basically, containers were a way how to standardize how you package something.
have everything in one computer, and instead of dividing in different computers, you have only one, but different, like in different containers.
Not yet. Not yet. Containers were more about two things, and I'm getting there. It's how do you package it into something like a box, right? Imagine a shipping container, right? Kind of, if you want to ship something from Costa Rica to States, you put it in shipping container, right? Now, the one that is driving that boat that has no idea, does not care what you put there, right? If I would package a lot of Java applications, that person does not know what it is, doesn't care, right? It's how to standardize shipping is why we got shipping containers, right? And the same thing is for applications. You give me a container image, that's just a format, how you package it, and I can run it. And I don't care what you did with your code, right? And then that time, the way how to run that package was Docker, right? Docker runs on a server, you give him an image, and it says, yeah, I'm gonna run this thing. I don't know what it is, I don't care what it is, that's your problem, but I can run something in that server.
Docker's like a mini computer.
Like more or less, yes, kind of, it's like a computer within a computer.
Like, is a way to run your project as your project, and you have to like change it, the framework to
So
another one.
a Docker container is like a mini computer, and the answer is yes, but
You have to.
you can't hook a keyboard to it. You can't change it when it's running. You have to change it somewhere else. So it's like a computer that's running an application in space where you can't possibly change what's happening. You can, but you have to remake it and redeploy a new thing.
Imagine being, if I go back to shipping, right? That's a shipping container. We know how to ship it. We don't care what's inside, and nobody can open the container. Kind of like,
Yeah.
nobody can change it in any form of way. And that's important. That's what we call immutability, right? The way how to reliably say, hey, is my application running? Yes. And I know it's running because nothing can change it.
Okay,
Right.
you have to if you want to change the project, like you have to remake the Docker
Yes.
from zero.
New image.
You'll recompile.
So it would be, if I would go back to the shipping container, you take the container out, put a new container, right? And I still don't care what's inside of that container. But if you want to change the contents, what is shipped in that container, you cannot open it. You take it out, you put a new one.
Okay.
So our whole world is nothing to do with writing applications. Instead, it's about how do we run the applications that are already written. That's what DevOps or cloud native or all of the things. So at an application writing level, there are these 12 factors that help you write an application in a way that's going to make it work as well as possible for those of us who are trying to run an application. Just backing up a little bit before we get too far into it. Do we have a question? Yeah. Yes.
I have a question about which is the best cloud service this time?
Which in the history lesson we're getting, What's the best service?
Cloud service.
Cloud service. At this moment or in Victor's story?
I'm old.
Nowadays.
At the moment. What's the best cloud service? And by cloud service, do you mean Google Cloud versus AWS versus Azure? He's the more opinionated one of the two.
So this is personal opinion, right? Different people have, the big three are AWS, Azure, Google Cloud, right? And they're very, very different. No, did I say, yeah, Google Cloud, Azure, and AWS. AWS is probably the best because, Amazon, yeah. I mean, I will say that all three are the best, just I'm getting there, right? Amazon in AWS is very low level, basically. You cannot say, give me a cluster, or give me a database. You need to combine, to get a database in AWS, you need to combine something called RDS, which is database itself, with subnets, which is networking, with VPCs, which is also networking, with storage. You need to combine 57 different things to get one thing that makes sense, like a database, right? So it's great because it's very low level, and that allows you to do things whichever way you want.
So you have more control.
More
Yeah,
control.
and you'll see that trade-off over and over and over again in tech. You can have more control, but then you also have to deal with more complexity. Or you can have less control, and it can be easier to deal with. So across so many things, you'll see that over and over again.
Google Cloud does not give you low-level details. So you don't have that much control, but it's so easy. It's kind of, give me a cluster. Kind of like, you literally, for AWS, you want a database, you need 57 different things. In Google Cloud, you say, give me a database.
So most of the time, because, for example, Google Cloud, for example, you cannot manage most of the things that it provides. So,
In Google Cloud, you can have a managed version of most things that,
Yes.
that Google Cloud provides, yes.
So think of it in a way like if you shop in Amazon right now, right? The only thing you can select is your address, and you have no control when it will arrive or how it will arrive and stuff like that. And that's good because it's easy. But if you want more control, then AWS. But if AWS would be equivalent of Amazon shopping, then you would need to fill in, oh, I want it by a truck or by a boat or whatever. So they're very different because of the levels of abstraction, what we call, right? Easy, one thing, database is one thing, not much control. AWS is the other extreme, 57 things combined, a lot of control, very complicated.
I'm right on Azure.
Azure is somewhere in between.
Oh,
Somewhere in between.
Yeah.
well, I guess it depends on what you need. Like, if you need more control, I guess the best one is AWS.
Amazon.
Probably, yes. Yes.
So then-
But you also drop, your hair switches to gray very, very fast with AWS. Because of all the...
All that control means so many things can go wrong.
Exactly.
We have a question here.
What do you think about use of free clouds for develop node project? I think,
And for a node project,
well, when I have like the data part, like the project of the database, and I have a project for the backend, and then a project for frontend. Well, I could use AWS for the data project, Azure for backend, and Google Cloud for the frontend. It is good to me
Now, I need to ask a follow-up question.
First-
What is the objective, for you to learn or to really run it?
repeat the question for those in the room.
first to learn, but at the same time for maybe security, because the AWS fails, well, not AWS, maybe Cloud and Google Cloud fails, I have still having the project of the backend and the database. And I could release or deploy a new project, maybe in Google Cloud again.
So the question is, should we use 3 different clouds for 3 different parts of the application? Should we do front end in Google Cloud, back end in AWS, database in Azure? Would that help with security? Would that help with resiliency?
The short answer is no. Because as I said, kind of those three, front-end, back-end database, are in 3 different clouds. One of them fails, nothing works, right? Until you start running it again. What if your resiliency? So, and that's what I was getting with Kubernetes. I'll skip it for a second, right? The first step you want to do. So I'm going to go in levels, right? First, you start by I'm running this application frontend on a server, right? That's your single point of failure. Doesn't matter whether it's in Azure or AWS or wherever it is. That server is down, or your application is down, nothing works, right? Now, so from there, that's where we moved into Kubernetes, where you say, you know what? I'm going to run my front-end application as 3 replicas. I'm going to have 3 copies of my front-end application.
Do you have different providers?
Right now, I'm in one provider. I'm going to get to different providers as well. But for a second, just forget providers for a second. I have 3 replicas of my something, whatever it is, database, back and front end, right? So if one of them goes down, I have 2 other ones. Now, what do I need to do for that? I have on top of all that load balancer, so that when somebody says, goes to my website, load balancer says, which one of those 3 is okay? This one, I'm going to send it there, right? And repeats the process for each one of them. But that's not enough either, right? Because those 3 copies of your applications replicas running on 3 different servers, if the whole data center goes down, still nothing works. That saves you from one server going down, right? So then we move into saying, okay, how about if those 3 replicas are running in 3 different servers in 3 completely separate data centers, right? Like in US, that would be, if you go to AWS, you would see US East region. And then there is US East A, US East B, US East 1C, right? So those are completely separate buildings with separate electricity, separate network, but it's one cluster, right? One cluster is a group of servers. So you're running in 3 of them, right? In 3 different buildings, 3 different data centers, whatsoever. And then if one of them goes down, you're safe, right? And then if you want to go further away and say, oh, what happens if the whole AWS goes down? First of all, very unlikely, because those are all separate data centers, right? You cannot destroy whole AWS. Something can happen to one data center, but not to all 3 of them. But you can say, okay, I'm paranoid. And then you can say, let me run not backend here, frontend there, but let me run one copy of each of those 3. And I'm saying 3, normally it's thousands, right? One in AWS, one in Azure, one in the Google Cloud. But then you would have the same rule for backend also, here, here, here. Database, here, here, here. Not instead of what you initially said, oh, frontend here, backend here, because that does not save you from failure, right? Okay. And that's where Kubernetes is coming in, because now imagine that you have, oh, I have one copy of my application here, another here, and I'm saying 3. Imagine you have 30, or 100, or 1,000, right? Who is going to watch over all that, right? Who is going to sit in front and say, oh, this one is down, I need to bring it back up. Oh, the server is down, let me move it over there. Oh, the cluster is, the whole data center is down, let me move everything to the one that is alive, right? And that's what Kubernetes does. It's almost like a human operator that is constantly watching and saying, oh, this is not working, let me put it there, right? As long as you designed it in a way that it runs in multiple data centers and so on and so forth.
So Kubernetes is software that runs your software, is the most simple explanation. And it's way, way more than that, but I think that's a great starting point. We have a question? Oh, yeah.
My answer is answered.
Your question is answered. Okay.
Oh, it's answered? Okay, excellent.
Si alguien tiene dificultad puede preguntar en español y yo lo traduzco busco inglés, oye, lo traduzco en inglés y nos apañamos.
Yes.
I'm confused with this thing. It's all new for me. But I have a question because all you two are talking is how it works. But I have a question.
Yes.
I grabbing phone to say.
Great.
Sure.
And what are the key concepts every programmer should understand before using Kubernetes?
Say that again, please.
And what are the key concepts every programmer should understand before using Kubernetes?
What are the key concepts every programmer should understand before using Kubernetes?
Before even starting with anything in Kubernetes.
Before.
Linux.
Linux.
Yes. Linux is basically, think of Kubernetes as operating system on top of Linux, but it's not, Linux is operating system for a machine, just as Windows is an operating system for your laptop, right? Now think of Kubernetes as being operating system for a group of machines, kind of is putting them all together, and that's the operating system of it, right? But everything is based on Linux principles. If you don't understand Linux, you will have difficulty understanding Kubernetes, right? Or even if you go slightly between, if you don't understand containers, you will also not be able to understand Kubernetes. And containers do not exist.
It's like a shell, right? It's
No. Containers is Docker almost doesn't exist. Docker is a wrapper around things that already exist in Linux. Most people don't know. There is something called C groups, something called namespaces, and so on and so forth.
I'm gonna disagree. Like, knowing Linux means such a huge thing. Like, talking about C groups and...
No, not that level. I'm not going to spend
you don't
7
need
years with Linux.
Like, you should know some basic, you should know your Linux terminal, you should know, when I was first starting, I got a book of Linux commands, just to understand how to run commands and how to navigate around Linux. I would not say I knew Linux very deeply at all. I just was comfortable in the terminal. So I'm gonna change what he says. You don't have to know Linux, you just have to be kind of comfortable in the terminal. Yeah.
Which is knowing Linux.
Just knowing Linux, a little bit.
Yeah, so Docker's like a machine, but only the terminal.
And Docker is something completely different. It's a container runtime. And it used to be the container runtime, but now there are lots of different container runtimes. So,
By the way, and this is very confusing usually for people, most of the time we don't have any graphical user interface. Most of the time you see only terminal.
yeah.
And the reason is very simple, right? Because if you go with, let's say, graphical user interface like Windows, right? Cool, great. But now imagine that you're using that something to control hundreds or thousands of servers. if it cannot balance the traffic, if it doesn't keep the state somewhere, and so on and so forth, then it's a whole long list of things. But the way how most of us operate now in software industry is that you're specialized in something, right? You're a Java developer, you're a PHP developer, right? You're making Kubernetes. But everybody needs to know a bit of everything, right? Because if you don't, same thing with security and many other subjects. If you know nothing about it, then whatever you're doing will not be good.
How are we on time?
How scary are you?
It's two, but I think that ya, pregunta chicos. Ya lo saben, ¿ven? Pregúntenle en español, pregúntenle en inglés, no hay problema.
For me?
For me?
For you? Oh, I'm Kurt.
What kind of challenge have you faced in this world of programming?
As a woman, what kinds of challenges have I faced in this world of programming? It's a very good question. One of the big challenges I face, especially at first, is that I kept trying. People would ask me to organize things. They'd be like, "Oh, you should organize the office. Like it's somebody's birthday, maybe you can organize the thing." Or like it's even someone's like, "Hey," one of my managers was like, "Hey, we should have a women's group as part of our pod. You should organize the women's group." And I'm just like, I understand that it's cool to have a women's group, but I want to do technical things. And at one of my jobs, I got this meeting put on in my calendar, and it was 5 hours a week for 10 weeks. It was a big time commitment. I didn't recognize who put it on my calendar, and it was a soft skills thing. They wanted me to help train, onboard like new people to our particular organization. And I was working on an OpenShift lab, like making a Kubernetes lab to help enable my coworkers. I was doing a technical thing that I was excited about. And so I just declined the meeting. I don't know who put that on my calendar. I'm not doing that. And so my manager had volunteered me for this position to help onboard people, and when I declined it, I made him look bad, and he was really upset with me. But it was like, I want to stay technical. And so I think I had to like be a little feisty and be a little bit like, no, I'm not doing that. And because over and over again, people are going to keep pulling you away from technical things. And so I recommend you stand up and like, no, I'm technical. Don't do that. Yeah. And you can say no, and people won't push back too hard too, more than you realize, maybe. Yeah.
I think that's probably more for women than for men, but also depending on the race and many other things or where you come from. Some genders or some nationalities or skin colors or whatever you want are more likely to say no than others. Those who say no prosper. Because basically, there are all these things that company or people need to be done that others don't want to do because they want to do cool things that will help them in their careers, and then the person who doesn't say no ends up doing, I will not say shitty, I can't say shitty on life, very kind of like uninteresting job without opportunity, right? Say no.
Say no. Yeah.
Okay.
Yeah. Any other questions?
On the Kubernetes,
About Kubernetes?
which language is the most available for operator create?
Yeah, so I'll repeat, which language is used to write Kubernetes operators?
Plus Java, Python.
So most of Kubernetes, so there is Kubernetes, so first think of Kubernetes as being a base, and then when people say I run Kubernetes cluster, it's Kubernetes and a bunch of other things. But Kubernetes itself is close to 100% written in Go, Geo or Golang. Most of the ecosystem around Kubernetes is also in Go. And that is very often happening in industry that for certain types of tasks, we end up picking one language, like most of ML, machine learning, Python, right? Most of front-end, Node.js. In case of Kubernetes, most of it is written in Go. Now, here's the thing. At least in my case, early on, when I hear kind of, oh, I know, back in the day I started writing with Pascal, but probably nobody heard of here, right? And when I was faced with, oh, some other language, and that was so complicated and demanding, but the truth is that the real challenge is how to learn how to write code, not how to learn some specific language. Experienced developer can switch from one language to another in no time. No time. Give me something in Rust. I never coded in Rust. In a week, I will be able to do it, right? So it's not that demanding, and it's very common. In most organizations, you will see many different languages depending on what they're doing, like, oh, this is better for this type of tasks, and so on and so forth. And another thing,
that'll come for you naturally. You don't have to stress about it. Like, you'll just start recognizing patterns that happen across different languages or different technologies, and then you'll be able to implement those.
Another thing also that might sound counterintuitive, people very often pick languages or technologies depending on what is most used, but opportunities are usually elsewhere. Like, being a Go programmer gives you more opportunity, or Rust programmer. Like, almost nobody uses Rust. But being Rust programmer, if you speak only one language, is probably going to give you more opportunities than being a Java programmer, right? Because that's a language in demand, even though not everybody might be using it. So, and in any case, explore different languages. If outside school, doesn't matter, kind of like, you need to learn at least 2 or 3 over your career.
Over your career.
Yeah, not today.
So, Kubernetes, which are the best languages that you recommend us to start learning?
The question is, which languages do you recommend us to start learning?
Yeah, like
For what?
like for
Getting a job.
to be updated on this, on the
So, kind of, like the kind of, right, if I would start learning language right now, I would probably learn Rust.
Rust.
Rust. And R-U-S-T.
R-U-S-T, Rust. Golang is one that you recommend us to learn, like because it's linked with Kubernetes, right?
Yeah, Golang would be my second choice, yes.
Sure.
But now if you ask me, which language is the most used on a planet, that's Java. And it's a different answer, right?
Java, Rust.
Right, because...
He didn't say learn Java, he said it's the most used Java planet. Those are two different things.
Yeah.
Yeah, but I mean,
like, actually, you know, one of the most used systems on a planet right now, actually, one of the most used languages on a planet right now is Fortran.
Fortran?
Fortran, mainframe, from 70 years ago. And most companies still run it. The fact that it's everywhere does not mean that it's good for you as a career, right?
Even if you did learn it and got a job, then you'd be pigeonholed into running
Forever and ever.
forever and ever. You wouldn't get to do cool, new, cutting-edge things.
Right? Because there is very often in our industry there is a difference between. So you have enterprise companies that usually are very traditional and I don't want to change anything. I want it to be the same as it was 20 years ago until they go bankrupt, and that's it, right? And then you have cool new startups, right? Those are the companies that will become next Google, right? They're writing things in Rust and Go today, right? So it depends on what you're looking for, right?
if I'm looking for it to be a full stack developer in the new interface.
Don't be a full stack developer, first of all. Let me explain why. So, for a small company, or for a company that doesn't have to be small, actually, that's a wrong thing to say, small company, right? Small scale, small operations, like something not important. Yeah, being a full stack developer is great, because I have a person, you, who can do front and back end database, cool, right? But when we go into real difficult situations, like I work in Netflix, for example, right? They serve zillions of users, huge scale, right? A person in Netflix, and I'm using Netflix as an example, just to be clear, cannot be full stack developer because they don't need a person who knows a bit about front end, back end, and data.
It is someone who knows the whole thing.
Yes. No. I need somebody. No. The other way around.
The other way around.
I need somebody who is so good that he will make our databases be able to run 1 million transactions every single second. No. I mean, I'm using performance as an example, but what I want to say is that I want somebody who really knows this. And if you say, I'm a full stack developer, then you need to know a bit of everything, but nothing a lot. Right? But yeah, now you're young, kind of like you're just starting. It's okay, kind of full stack developer, right? You cannot know much about anything anyways, right? But over time, you become specialist and you say, oh, this is what I know. Then now, a backend developer will still know how to create a frontend, and backend developer still knows how to create a database. You can call that backend developer full stack, but he's really focused. He knows go inside, or she knows go inside out, right? Understands, and there's much more than writing code always, right? So.
And in general, if it's a huge company, the more likely your role is to be super specialized. And the smaller the company, the more likely you're going to know a little bit about everything.
What is the best, like, front end, back end? What is the best?
One of the things I said in my presentation is just be curious. Try not to have so many opinions. I don't like all of this, like, what's the best, what's the best, what's the best.
Like, in this, like,
Can you put CNCF on slide here?
Oh, yeah.
Okay, so let me change your question, just because of this illustration. Which cloud native project is the best? I want to demonstrate something.
It's going to take a second.
Okay, anyway, going back to your question. There is no best because things are changing all the time, right? There are things that are, so many companies are using React for frontend, right? But never think in terms of best, because by the time you finish university, React will probably be replaced by something else. It changes all the time, literally. So so here's the story. I published a lot of books. And I write books usually on cutting-edge technology. And it takes approximately 1 year to write a book. And every time I finished writing a book a year later, and I was about to hit the button to publish, I thought to myself, why the heck did I do this? This is trash. I don't use this anymore. This was so good and useful by the time I started writing it. By the time I finished writing the book, I myself, the author of the book, think that that's not good anymore, right? So never think in terms of what's the best, because simply it changes all the time. Like if you ask me for AI, okay, so kind of this is.
We talked about Kubernetes. There are more than 200 different technologies that run on top of Kubernetes that help make Kubernetes better. So these are all like Kubernetes integrations that help you do things like scaling or replication or adding databases or running your container images or pushing your images to a registry. There's like observability. There's so many ways to enhance your Kubernetes cluster, and there are new ones coming out all the time.
Okay. Now, if you ask anybody, and I said I'm using this as an example just because it popped to my mind, but the same thing goes for front and back and whatever you want. Which one is the best? It depends.
Yeah.
First of all, nobody knows all of those, so nobody can answer it from practical experience. Second, they all do different things and behave in different ways depending on the situation. Somebody will choose, a company might have a front-end in React and then some other front-end in some other technology, because for that use case, it works better, right? And this is, what did I want to say now? I kind of thought it would come back to me. Yeah. This is similar also to the question of you had before also about, not question but comment about full stack, right?
Yeah.
This would be similar to full stack. Say, okay, so I as a Kubernetes something should be full stack Kubernetes. I should know all this. Nobody does. Nobody does, right? Nobody can be expert in everything.
Yeah. Okay. Yeah. Like it's better if you learn more about something in specific.
So here's what I think. Find something that makes you excited. Or find something you want to build and build that thing. And maybe when you build it one way, and then when it's built, you're like, oh, what if I build it this other way with this technology? And you get a sense of how these two different things work. Like you can't know what's good. We can't tell you what's good. You do stuff that makes you happy, stuff that makes you excited. That's going to naturally make you grow and make you be the best person you can be without trying to like chase what's good or yeah.
And, you know, when you're starting with something, let's say first time you start programming Java, takes a lot of time, right? I don't know, half a year, 5 years, nothing else, right? And then you think, okay, so I need to make the right choice because it takes so much time. But that's not true. But whichever you pick up next, it takes less time, and less, and less, and less, and less. Like, I earlier said that I can pick up a new language that I never saw in my life in a week.
Yeah, because
right?
it's not syntax. It's all syntax.
Not only syntax, but also they're all built on similar principles. They're all built on top of each other. Earlier I said learn Linux, right? Why? Because containers are a slight improvement on top of Linux. If you know Linux, you know container. You need to learn this about containers, but this amount is the same, right? And then Kubernetes. Oh, Kubernetes is massive. But there are so many things that if you know it from before Kubernetes is not that difficult, right? So it's more important to experience different things than to pick one thing that you will be for life.
And if you pick one thing that's the best, you're putting so much pressure on yourself and on that one thing. It's more like just do more and play. And who cares if it's good? And later you'll figure out what good is. But don't worry about good yet.
I picked Pascal as the best. Pascal, yes. Nobody used it for 30 years.
Yeah.
But when I picked it, it was the best.
Okay. No, yeah, I asked that question because I like to be updated on this because every time they release or they launch a new version of things, for example, Python, it's being updated every time. Like now it's 3.13 and the last week was like 3.11.
So he said he's asking the question because he likes to be updated.
Yeah,
which brings
I
up
asked that to be updated because every update it's more like better for the performance of everything, and like it's like my aim. I want to be like updated.
So the aim is to be updated, and it's impossible to be completely updated all the time.
Yeah, but
No, I think there's a question there. I'm not like what. I'm gonna ask you, like, how do you find the right balance of things you stay updated about and times you just move forward? Because you literally can't be updated about everything always.
Yeah, but you do need, I cannot give you the number of hours a week. But yeah, everybody should be spent, no matter whether you're studying or you're like already 30 years in career, everybody should dedicate time to play with new stuff. New version of Python or new language or whatever. Like in the past, I'm lucky, I spend most of my time exploring new things right now because that's my job. But even when I was working in a normal company like anybody else, I would dedicate every Friday or every Saturday kind of just, I don't know, let me see what's new in Python. Yes.
No, and it's also funny, like, because you know new features that you probably saw like hard to make, and now it's probably easy. And it's funny for that way. For me.
Not only that, but the more you get informed, the more you try things, the less time you will be wasting on doing something that was already done many times before, right? Kind of like most of most of us developing, 95% or 99% of the code you're writing, that's been written thousands of times before.
But you do need to write it for your own learning. You
Well,
can't
yeah,
skip
you probably,
it. Yeah.
if you want to, like if you want to know how to do it by yourself, you could learn it like from zero. If you want more like make something fast, you can use new features and things.
Yes and no. It's good to strike a balance.
Yeah.
Kind of, hey, use this library to do this for me, but maybe spend a couple of hours going through the code of that library to understand what it does, right? So kind of like use things, don't do it yourself always, but also try to understand what you're using. Don't just use it kind of like, library, I don't know what it is. So always balance between understanding what you're using and using it.
You cannot run without knowing how to walk.
Or without shoes.
That's one. Okay, thank you. Guys, closing, algún comentario para cerrar? Ya como
Yes.
cerrar. ¿Qué es por closing?
To Kubernetes, let me see if I get the idea of the example that you with. In my example, you said that I could have a copy of database up in the front end on these three services. So with Kubernetes, I can configure or program like a way for have like updated database on the three services at the same time, and to maybe to optimize the way if some service is broke or the other take the space.
So to rephrase the question, we're talking about the same application architecture we talked about before with the front end, back end, and a database. And how specifically do we use Kubernetes to manage all of that together?
Three services.
Three services in the cloud.
Yes. So the change with Kubernetes, not only with Kubernetes, but some other things as well, is that in the past we were doing things imperatively, meaning that, oh, I go to this server, I do this. I go to that server, I do that, right? Working with Kubernetes is like writing a contract, right? And you say, you know what? I want to have this application based on this container image, and I want you to run 3 replicas, which is 3 copies, right? And then Kubernetes, from there on, basically sign the contract. Literally, as if you sign the contract with a human, right? And then Kubernetes has the means, and first of all, since it is operating system of many servers, it knows, okay, so I have a server here and here and here, I'm going to put one there, I'm going to put one there.
So whoever set up Kubernetes in the first place told Kubernetes, this is how many computers you have to be able to run all the software, where you can put them. So your Kubernetes cluster might have 6 nodes, 6 computers, and might have 100 nodes, 100 computers. But you, as someone deploying to Kubernetes, you don't have to worry about which of your replicas is going to which node. Kubernetes is solving that problem for you.
The second part is that it is solving that problem for you eternally, forever and ever.
Forever and ever.
Meaning that's why I like the word contract, right? You said you want 3 replicas, and Kubernetes will be constantly monitoring and saying, okay, so right now there is 0 because we just started. Put one there, put one there, put one there, right? And then it continues seeing, and then at one moment this one fails. Says, oh, you said 3, and right now I see 2. Let me create a new one over there, right? So it is constantly checking the state of everything that you declare that you want and correcting it. So it's basically like a human sitting in front of the monitor watching what's happening, and whenever something is different than what you declared that you want, it performs certain actions to do it. And you can say, and I use the example of 3 replicas. You can say, you know what? no replicas. I want you to have I want you to run one replica for every 100 users using my application in parallel. And it says, oh, okay, so that's the contract, cool. How many people are right now using my application? 500, cool. 5 replicas. And then a moment later, there are 200 people using your application. Oh, Victor said that he wants 1 replica for every 100. Right now there are 200, let me kill 3 of those, right? So it constantly tries to fulfill your desire. It's like a genie, right? Genie in, what's the word?
The bottle.
Huh?
Genie in the bottle?
Yes, right? Kind of like you say that's what you want, and that's what's going to be forever and ever.
And so
It
now,
doesn't work always, but that's the
instead
idea.
of having like so many computers that are running at your company, you're leasing computers, like computers from a cloud service. And that cloud service, like on the day, on Thanksgiving, your retail application is really small, but then on Black Friday the next day, it grows hugely. In the before times, before Kubernetes and cloud computing, a toy store might have a really huge data center, even though it sits empty most of the time, just ready for Black Friday. But now you can be way more efficient with how you use your computing and get a lot when you need a lot and scale it down when you don't need a lot.
Yo puedo hablar hasta
Ok, les damos un fuerte aplauso.